Class 10. What are the origins of ocean currents? The origin of the ocean currents are dependent upon Earth's rotation, wind, temperature, and salinity of the ocean water, density of the ocean water, melting of the ice, shapes of the coastline, and seasonal variation. Now, how does the Earth rotation is responsible? Now, Earth rotates from west to east. Due to this rotation, that is, deflects all freely moving objects like wind and ocean. I have shown you in the class how the wind is deflected. Same, the ocean current is also deflected in a clockwise direction in the northern hemisphere and in the anti-clockwise direction, that is in the left in the southern hemisphere. Okay, now wind. What are prevailing wind? It is the wind. Prevailing wind is the most important causes for the origin of ocean currents. These winds, they move freely from the vast ocean surfaces and drag the surface water to the direction in which they blow. I told you the last class here I showed you that when the wind is blowing, it pulls the water with it because the water is touching the wind is touching the water, and the friction of it pulls the water in the direction it moves. These winds move freely over the vast. As it is moving freely, they drags the water here and there. Drag, not here and there doesn't mean like that only. Here and there means they move freely in the direction in which the wind is blowing. Now, temperature and salinity of ocean water. As the ocean is not equally being heated up everywhere, somewhere it is less heated and somewhere it gets more heated. How? Because the places near the equator gets more sunlight. As the sunlight are straight, so the water in those areas are more heated. Whereas the slanting rays in the Arctic areas and in the Antarctic areas, they get less slanting sunlights, and being in the polar regions, water is not as much heated as it is in the equator, due to which there is also variation. Now, what is the variation? The water in the equatorial regions sees the water is getting heated and it expands and becomes up and flows towards the pole as surface current. Whereas the water in the polar regions is cooler and heavier, so they sink down and they move towards the equator along the sea floor. That means downwards, near the bed of the sea or under the water as undercurrent. Water of high salinity, that means which contain more salt, is denser and heavier. They sink down and flow below where the water is less saline under that, while the water of low salinity, being lighter, they rise up and flow along the surface. Thus ocean currents are caused, and these are known as thermoline circulation. Density of ocean water. Difference in density controls the flow of density current. Density of ocean water depends on the temperature and salinity of the water. The density of water decreases if temperature increases and increase if the temperature decreases. The water which is more saline becomes denser than the water which is containing less salt. While the water is colder and denser, polar currents therefore sink. As we told, polar currents being cold, they are sinking and it have saline, so it flow towards the equator, while it sink and flow. It is not flowing at the top level, it is flowing under level and it comes towards the equator, whereas the water with less salt contain the colder and denser polar currents, therefore sink and flow towards the equator, while warmer and less dense tropical water, they move, the one which is near the equator, they move up at the top, remain at the top, and they move towards the pole region. So this moving is going on thoroughly. Now what happens with the melting of ice? Melting of ice at fresh water due to the melting of Arctic Sea ice, there is less dense because it is fresh water. At high altitude, researchers found that due to melting of Arctic Sea, there is influx of fresh water, which has caused the sea water in the Arctic region less dense because it is having the sea water, the glacier, it is melting and coming and falling in the Arctic Sea. So the water is not so dense, being at the cooler area also. So the less dense water will not be able to sink and circulate through deep ocean, and it does not as it does at the present. This will therefore disrupt the slow down and flow of the current. Next is shape of the coastline. So these are the shapes which we are talking about. Shape of the coastlines influences the direction of the currents. They form the position of the Cape Saura in the northeast Brazilian diverts the south equatorial. See, here it is the south equatorial current to the south of the Brazilian current. As there is little land here, the land is very little, and poleward of 40 degree south latitude, and the west wind drift circles all these major oceans. It is coming in an ocean from Pacific, Atlantic, and Indian. As cool Arctic circumpolar draft, part of the this moves this side and becomes the Arctic polar drift, circumpolar drift. Next is seasonal variation. Seasonal variation is the movement of the ocean current is mostly affected. It is now mostly seen in the Indian Ocean. The currents in North Indian Ocean change their direction from season to season to respond to the seasonal rhythm of the monsoon. In this part, the Indian Ocean, there is a clear reversal of current between water and warmer in winter and northwestern eastern monsoon drive the water along the coast of the Bay of Bengal to circulate in a anti-clockwise direction. A similar anti-clockwise circulation develops along the Arabian Sea also. In summer, a strong southwest monsoon causes clockwise circulation of water in the northern Indian Ocean. Okay. Thank you.